A meter bridge is set up as shown in figure to determine an unknown resistance X using a standard 10 ohm resistor. The galvanometer shows null point when tapping key is at 52 centimeter mark. The end corrections are 1 centimeter and 2 centimeter for the ends A and B. Determine the value of X. So we need to find the value of unknown resistance X. Okay, so we need to find the value of unknown resistance X. Now we know meter bridge. Okay, meter bridge works on the principle of Wheatstone bridge. So we need to note this. So we have to design Wheatstone bridge circuit for the given meter bridge setup. So I'm writing, therefore, we need to design Wheatstone bridge circuit for the given meter bridge setup. So this is to be noted. Okay, so we have to design Wheatstone bridge circuit for this given circuit. So I'm erasing this. Okay, now we can see in this diagram, okay, we have battery between A and B, and the positive terminal of battery is connected to terminal A, and the negative terminal of battery is connected to terminal B. So this is tap key. Okay, so when we press it, the circuit closes, and when we release it, the circuit opens. So we have this, and let's call this as A, and this is B. Okay, and let's call this terminal as C, and this is the position of jockey where we have a null deflection. So this is jockey. Okay, this is jockey, so I'm writing in this way J, and at this position of the wire, okay, we have null deflection. So we have this. So we have galvanometer between C and D, and let us call this as C. This is another tap key, so this is K2. We have galvanometer, and this is D. So what we do, we close key K1 and then we close key K2. So what we find, the galvanometer shows null point when tapping key is at 52 centimeter. So we close K1 and then we close K2, and we go on sliding jockey from A until we get null deflection at D. So this is to be noted. Okay, now what we find is that, okay, when we compare this circuit with this, okay, so this is what, this is Wheatstone bridge circuit. Okay, this is Wheatstone bridge circuit. Wheatstone bridge circuit. So we find resistance X between A and C. Okay, and we have standard, we have a standard 10 ohm resistor. Okay, so this is 10 ohm between C and B, and we have galvanometer between C and D. So we have this. Okay, now we need to find the resistance of the length AD, and we need to find the resistance of the length DB. And what we find, the galvanometer shows null point when tapping key is at 52 centimeter mark. So we slide from A. Okay, keep in mind, we slide from A. Why? Because A is at higher potential to B, and B is at lower potential. So we slide from higher potential to lower potential. So we have null deflection, okay, at D, and this length is 52 centimeter. Clear? And we know the total length of the standard meter breeze is 1 meter or 100 centimeter. Therefore, the remaining length dB is 100 minus L. So this is in centimeter, okay? So we have this in centimeter. So we have this. So let me write in this way, okay? Right now, okay? So I'm writing in this way in the form of formula, okay? So we have this. So keep in mind, L is 52 centimeter. So we have this. Now, let small r, okay? This is resistance per centimeter of the wire, okay? Of meter breeze. So we have this. Therefore, okay, resistance. So as I said earlier, we need to find resistance of the length AD. That is, we need to find resistance between A and D, or the arm AD, okay? And we need to find the resistance of the length DB. That is, we need to find resistance between D and B, or resistance of the arm DB. So resistance of length AD. So we need to find this. So what we do is that when we multiply, okay, L with R, L is in centimeter and R has unit resistance per cm, okay? So this cancels out. So this product, okay, has unit, okay? It has unit ohm. So we need to understand this, okay? So therefore, what we do is that, okay, resistance of the length AD equals L times R. Similarly, okay, resistance of length dB equals 100 minus L times R. So we have this. Okay. Now what we get at balanced condition, okay, at balanced condition, we get this, okay, ratio of x by 10 equals ratio, okay, of LR to 100 minus L times R. So we get this. Or we can write in this way, x by 10 equals resistance of length AD by resistance of length dB, and we know this is LR and this is 100 minus L times R. So we have this. So let's call it equation 1, and we are writing equation 1, okay? We are writing equation 1 without considering end correction. So we need to note this. Clear? Now, when you see in this question, okay, so I'm writing over here, this is LR, this is 100 minus L times R. So we have this. Clear? Now what we find, this cancels out, okay? Therefore, finally, we can write in this way, okay? So we get this. Finally, we get this. Okay. Now what we do is that we need to understand what is end correction, okay? Because we have end correction in the question. Now let's understand the end correction. End correction for meter breeze. So let's consider this, okay? So we have a two large copper strips, okay? And we have a small copper strip, okay, in order to provide two gaps. So this is left gap and this is right gap. And we find unknown resistance X in the left gap and standard 10 ohm resistor in the right gap. And we have wire, okay, between terminal A and B. So we have this. Now, in theory, okay, we take, so I'm writing over here. In theory, we take wire of length 1 meter or 100 centimeter. So this length. So in this case, we have wire AB. That is AB equals 1 meter. But in real experiment, okay, so when we do experiment in lab, so what we find, okay, what we find is that small portion, okay, we find small portion of the wire. So let's understand in this way in a magnified diagram, okay. This is A. So what we find is that small portion of a wire, okay, there is a small portion of the wire. There is small portion of the wire this small portion of the wire, okay, this is A, this is B. So what we find while doing experiment in lab, okay, a small portion of wire, okay, wire, let's say AB of the meter breeze, okay, of the meter breeze is under the solder, okay, at the terminal A and B. So we find this, okay, when we do real experiment, okay, in lab, what we find, small portion of the wire is under this terminal, okay, A, and small portion of the wire is under this terminal B. So we need to consider that portion of the wire, okay, in this numerical problem. So what we find, so when we consider that small portion of the wire in calculation, then we have to use the concept of end correction. So we need to know that, okay. Therefore, to find, okay, the accurate, okay, to find the accurate value of X, that is unknown resistance, okay, correction. So we need to apply correction to the length L, we are measuring this in centimeter, okay? So I'm writing in this way, L, and 100 minus L, this is also in centimeter, okay? So we need to know this. 100 minus L, this is in centimeter, is necessary. So the correction must be done to the length L and 100 minus L. And that correction is called end correction for the meter breeze. Okay, so I'm writing over here. Let me erase this, okay? So I'm writing, let E1 and E2 be the correction in centimeter, okay, in CGS system, to the length L, okay, centimeter, and 100 minus L centimeter. So we need to do correction to the length L and 100 minus L. Therefore, okay, we can write, after applying end correction, okay, after applying end correction, equation 1 in correction, equation 1 becomes x by 10 equals L plus E1. So we have E1, which is in correction, okay, in centimeter to length L, and we have E2, which is in correction to the remaining length, that is dB, which is 100 minus L. So we have this, okay, 100 minus L plus E2. So we have this, okay. So we are going to use equation 2, okay, to find the correct value of x. So I'm erasing this. Now, what we do from equation 2, okay, x by 10 equals L, and we know L is 52 centimeter, okay. So 52 plus E1 is, we see E1, okay. This is E1, clear? Because the end correction are 1 centimeter and 2 centimeter at the end A and B. So we need to consider length 1 centimeter at end A1, and we have to consider length 2 centimeter, okay, at end or at terminal B. So this is end correction E2. So we have E1, which is 1, okay, centimeter, and we have 100 minus 52 plus end correction is 2 centimeter. So we have this. So we have x by 10 equals 53 by, this is 48 plus 2. So x by 10 equals 53 by 50. Therefore, x equals 10 times 53 by 50. So let's find this, okay. 530 divided by 50. So we get x, that is unknown resistance, equals 10.6 ohm. So we can write, therefore, X equals 10.6 ohm. Clear?